transform India into a formidable global aerospace power, a comprehensive policy framework needs to be drawn. The policies should address both current gap and future challenges. The recommendations of the syndicate mainly focus on fostering technological innovation and operational integration in the aerospace domain. To strengthen India's aerospace research and development ecosystem, a paradigm shift is needed that fuses market and command-driven direction, mirroring the framework outlined in the book Nuclear Strategy, Nuclear Security, the Nexus Among Science, Technology, and Policy. The aerospace sector's complexity and strategic importance demand joint stewardship by government, industry, and academia. India should substantially ramp up defense research and investment, incentivizing collaborative ventures between DRDO, private firms, universities, and startups. This multinodal approach ensures that innovation is not siloed but synergized, much like how nuclear progress thrived in West through public-private academic integration during the Cold War. Establishing dedicated defense technology incubation hubs across industrial corridors would be instrumental in bringing convergence between diverse talent and technology. The government, in its command driver role, must provide mission mode funding and policy coordination to unify fragmented research efforts. Regulatory clarity and procurement guarantees will lower risk barriers for innovators and accelerate lab-to-field cycles. With coordinated investment and innovation, India's aerospace sector can evolve from reactive capability building to proactive technological driving force. India's aerospace sector is poised at a crossroad. It can either incrementally catch up or radically leap ahead. Drawing from Andrew Krapenwicz's Origins of Victory, the key to strategic dominance lies not in refining current system, but in disruptive innovation that redefines capability thresholds. Historically, the British Royal Navy's deployment of the HMS Dreadnought exemplifies such leapfrogging. It bypassed incremental improvements in battleship design and rendered existing fleets obsolete. The bold embrace of transformative technologies created a temporary monopoly in naval power until rivals scrambled to catch up. India must similarly embrace the fourth industrial revolution, or 4IR, to disrupt its aerospace trajectory. Technologies such as artificial intelligence, machine learning, and quantum computing can revolutionize avionics, hypersonics, propulsion systems, and unmanned aerial platforms. By leapfrogging legacy infrastructure and investing directly in next-generation capabilities, India can unlock a strategic edge in both defense and commercial aerospace. Central to this transformation is military-civil fusion in aerospace domain. By integrating civil research and development and commercial aerospace capabilities into defense planning, a cost-effective innovation cycle can be generated. Civilian breakthroughs like AI, 3D printing, and satellite imaging can be repurposed for defense application without reinventing the wheel. In the Russia-Ukraine conflict, Starlink provided resilient satellite internet to Ukrainian forces, demonstrating how private sector innovation assists defense architecture. Military-civil fusion fosters a distributed industrial base that can be scaled during conflict. Civilian aerospace firms, startups, and academic labs become force multipliers ready to pivot towards defense production and ISR and logistics. During World War II, the United States demonstrated the power of civil-military fusion when Ford's Willow Run plant famously produced a B-24 bomber every hour, converting its automobile assembly lines into a formidable war machine. In contemporary times, Iran mass-produced Shahid kamikaze drones demonstrate civil-military fusion. State-owned aerospace firms oversee research and development, manufacturing, and final assembly, while thousands of civilian knowledge-based tech companies under Defense Ministry direction partner with the IRGC, supplying specialized components, avionics, software, and extensive engineering services, thereby blurring the boundary between commercial and military industries. In essence, India's aerospace ascendancy demands a dreadnought movement, not a cautious upgrade, but a bold leap through disruptive innovation, 4IR-led transformation, and military-civil fusion. Stephen Peter Rosen, in his book, Winning the Next War, Innovation and Modern Military, offers a powerful framework for understanding how systemic change, not just technological upgrades, drives military transformation. Rosen argues that military innovation succeeds when it's embedded in systemic change, like new doctrines, new career paths, and institutional restructuring. It's not enough to adopt new technologies, the entire system must evolve to support it. Op Sindoor underlined several trends. It showcased the dawn of new age of warfare in South Asian context. It was the first time that India executed a multi-domain operation of such scale and complexity. Using Operation Sindoor as the inflection point, India should formalize its ability to conduct integrated multi-domain campaigns combining air, land, sea, cyberspace, and cognitive warfare through a dedicated doctrine. A few sub-policies have already been issued. However, much more needs to be done. Challenges are formidable in terms of interoperability between legacy and high-tech systems and cultural mindset. We need to navigate these issues through strategic and policy debates, professional military education, and training. In essence, Rosen's analogy teaches us that winning the next war requires more than new weapons, it demands new system. Indigenous development is not just a choice, but a national duty. India must innovate, produce, and secure its defense technologies to maintain a strategic edge. The performance of the indigenous defense equipment during Op Sindoor highlighted the success of India's policy emphasis on Make in India over the last decade. India must deepen research and development, streamline procurement, and foster public-private defense partnership to achieve strategic autonomy. While pushing for Atmanirbharta and continuing to exercise its strategic autonomy in global power play, India must actively seek partnerships with aerospace powerhouses like the USA, France, Russia, and Israel to gain access to niche aerospace technology. Technology transfer under joint development projects and collaborative research can accelerate domestic capability building by learning from established aerospace leaders. In today's warfare landscape, cognitive superiority, that is the ability to shape perception, accelerate decision-making, and assert informational dominance, it has become central to achieving victory in conflicts. Drawing lessons from India's experience during Operation Sindoor, it is clear that the battlefield now extends into the realms of minds and behavior. Victory is increasingly perception-driven, where truth-led strategic communication amplified through real-time ISR can neutralize disinformation and strengthen diplomatic positioning. This shift demands that aerospace forces act not only as kinetic platforms, but also as narrative instruments, helping establish transparency and credibility in conflict zones. Space-based ISR serve as powerful enablers of narrative warfare, transforming raw geospatial data into authoritative stories that shape public perception, counter disinformation, and enhance credibility. Ladies and gentlemen, in last 40 minutes, we have argued that warfare is a complex adaptive system. Air and space power, which are agents interacting in fitness landscape of MDO, can adapt and evolve to produce non-linear and unpredictable outcomes. Multi-domain operations are the future of warfare, and aerospace power is not escalatory, but a tool in the hands of policymakers. Technological innovation and its operational integration is the way forward, and thus our syndicate says that aerospace power is imperative for deterrence and for victory in war. Thank you.